We're going to do a brief covering of 6.3, sampling distributions and estimators. And essentially, we're going to be talking about what they are, and that's pretty much it. So the sampling distribution of a statistic is the distribution of all values of that statistic, maybe it's a proportion, a mean, or a variance, when all possible samples of sample size n are taken from the same population. So let's say you've got a population of 10,000 and you can't actually find the parameters. It's too big of a population. So you take many different sample sizes, maybe all of the same size of 50. And your answers are going to vary, but what ends up happening is they start to have a similar behavior. So we're going to take a look at those behaviors of the different statistics. So first we're going to talk about sample proportions. When samples of the same size are taken from the same population, two things happen. They become normally distributed or bell-shaped, and the mean of the sample proportions is the same as the population mean. Again, what does that mean? If we have 10,000 in our population and we take proportions for 50 different ones, so the value we want over the total, and we keep doing it over and over and infinitely many times, what's going to happen is the mean of those sample proportions is going to end up being the same as that population mean. So the notation for proportions are here. The population proportion is P, and then P hat is our sample proportion. And again, the distribution tends to be normal bell-shaped and target the value of the population proportion in the sense that we already talked about. The mean of all those sample proportions is equal to the population proportion. So again, if we take infinitely many samples of the same size, all of those samples will become normally distributed and get the same value. The average of those, the mean of those, will target the actual parameter in the first place. Now, if we talk about sample means, the distribution of sample means tend to be a normal distribution. Again, we're going to be talking about that more later, but if we take infinitely many samples and we find the mean of each of those samples, it's going to give us a bell shape, and it's going to target the value of the population mean. So the mean of the sample means, so each mean, this sample we get a mean of 1, next sample we get a mean of 2, next sample we get a mean of 1, next sample we get a mean of 3. And if we take the mean of all of those different samples, it's going to target the population mean. And lastly, we're going to be talking about estimators. An estimator is a statistic used to infer the value of a population parameter. There are unbiased and biased. The unbiased estimators are our proportion, mean, and variance, because these are what we just talked about. We didn't go into variance here, but that the more we take of those, the more they target that population parameter. And then biased estimators are our median, range, and standard deviation. We're going to go into these a little more in detail later, but for this section, all you really need to know is the definitions, and that's it. And that concludes section 6.3.